Hello guys, and welcome to another video. This video will be basically on Norton's theory. Okay, so we'll be treating Norton's theory. We've already done Kirchhoff's, Thevenin, and then we are now on what's Norton's theory. So in case you are new here, again, kindly subscribe. Okay, subscribe so that you don't get or you don't miss out on any uploaded videos, hence getting access to all uploaded videos and then getting the notification once any video is being uploaded. Okay, now so let's boss on. Okay, so when we talk about Norton's theory, just like what the Thevenin's theory, okay, we are trying to find the specific currents, okay, passing through a specific resistor. Okay, now again, just like Thevenin's theory, there are certain things you need to know, okay? But in this video or on this channel, I always upload videos which try to augment your studies, okay? You try to learn smart, okay? Not the hard way, okay? Not going through the traditional approach just like anybody else, okay? Try to, improve your study technique, okay? So now, this is how we represent the Norton circuit, okay? So you have the IN over here, the Norton's resistor, okay, and then the resistor through which this current is passing through, and then that is the resistor you are trying to find the current which is passing through. Okay, so now for Norton's theory, unlike Thevenin's theory, for Norton's theory you need to know three things. Okay, for Thevenin you just needed only two tips, okay, but for Norton you need three. Okay, so this is the first one. Okay, let me give you the green arrow. Okay, this is the first one. Okay, this is the Thevenin, okay, formula. Okay, yes, and then this is your simple approach. Okay, this is a simple approach. Now this is the third one. The third one is you need to know the Ohm's law. Okay, the Ohm's law, you know that Ohm's law is V, okay, equals IR, okay, but this is not the type of Ohm's law we need. Okay, so let me clean it. Right, this is not the type of Ohm's law we need, even though it's Ohm's law, okay, but this is the Ohm's law you need. Okay, this is the Ohm's law you need. This is the Ohm's law. Okay, so you have IN, okay, equals you know that Ohm's law is V equals IR. Okay, so we have V on R. Okay, so this is the Thevenin theory you need. Okay, this is the Thevenin formula you need. Right, so note R is RN, and then V is VTH. Okay, now I'll just introduce this formula to you and then I'll come back to it again. Okay, so keep this formula in mind. Very important if you want to solve questions or not using Norton's theory. Okay, right, so the next thing you need to know is you need to know that RN, okay, RN is equal to RTH. Okay, it means that the same procedure you use in finding RTH, that's the same procedure you'll be using to find RN. Right, so you know 0.1, 0.2, and then the main one, which is 0.3. Okay, so these are 0.1. The 0.1 is this formula and this formula. Okay, 0.2 is this, or I'll say pro tip 1. No, this tip 1. Tip 1 is the general formula. Pro tip 1, okay, is this, and then pro tip 2 is the second formula. Now let's dive right into how to arrive at this using the Norton's theory. So you have to find the current passing through the 3 ohm resistor. Okay, current passing through the 3 ohm resistor. So now all you have to know is this approach. Okay, the RIKR. So first you do yes, you remove. Okay, so you try removing the 3 ohm with A and B. Okay, so that's the first method. Okay, R, that's remove. Now let's move on to the insert. Okay, now we try inserting. Okay, Okay, but now we have a certain circuit, okay, circuit arrangement in this form, okay, like this, okay, like that, right, and then we have what? This is what removed, okay, so let me just omit that. So whenever you note that, whenever you remove what? A resistor, it becomes what? Using Norton's theorem, it becomes what? Short circuit, okay. So this will be a short circuit, not an open circuit, unlike what? The Thevenin's theorem, okay. So this will be what? A short circuit, and then represented by what? IN, okay. IN, and then we have what? A voltage of what? 35. Over here we have what? 42 volt. Over here we have what? 12 ohm, and then what? 6 ohm. Okay, so now you've removed the 3 ohm, okay, and then you've inserted your what? Short circuited current. Okay, now let's do what? Apply what? Kirchhoff's. Okay, so applying Kirchhoff's, that's the key. Okay, so applying Kirchhoff's, we have what? We choose loops. Okay, so let's label this circuit. Okay, we have what? Our A, B, C, D, E, and what? F. Okay, so now let's move on. Let's choose a loop. Okay, for Kirchhoff's we choose loop. So using Kirchhoff's, okay, KVL. Okay, using KVL. Sorry. Using KVL, okay, we have, let's choose a loop. Okay, so let's choose loop what's A, B, what's E, F, E. But before we do that, we have to, apply our current, okay, introduce our currents. Okay, so let's see. Again, from Kirchhoff's rule, okay, I hope you remember this approach, okay. Talking about this approach, how to navigate through the current application, okay, when you want to apply the current in your circuit. Okay, in case you don't remember, just go back to the Thevenin's video, okay, in our playlist, and then you just refresh your mind and then come back to this video. Okay, now let's move on. Now you know that this is what IN, so we can set a certain current over here and then another one from here. Okay, so it means that IN will pass through the entire of this circuit. Okay, so IN will be here. Okay, so it's moving in this direction. Okay, now so from here we know that this is what IN, so we know that for Kirchhoff's current rule, we know that current entering have to be equal to what? Current leaving. Okay, so now let's take this the loop at junction B. Okay, loop at junction B. Okay, so you know that this is what IN is what's leaving the node, but let's say we have this current to be I. Okay, let's say this current is I. Now this IN is leaving this node. Okay, so current entering the node must be equal to what? Current leaving the node, and then we have what? I to be what? Also leaving. Okay, now this is the only current which is what? Entering the node. Okay, this current is entering this node, so let's say this is X. Let's represent this current by X. Okay, so we have X, so it means that this X is equal to what? IN, okay, plus I. Okay, so this current is what? IN plus 1 I. Okay, right, this is not 1, it's I. Okay, so let me write this well. It's not 1, it's I. Okay, now let's move on. So from here you can notice that the same current will pass through here. Okay, that's IN plus I. Okay, the same current will pass through that. Now let's move on. So let's choose our loop. Okay, so we have loop what? Let's choose loop A, B, E, F, A. Okay, so we have what? A, B, E, F, A. Okay, so that will give us what? 42 volts. Okay, 42 volts equals what? Our 12 ohm. Okay, How about 12 ohm multiplying what? IN plus what? I, okay? Then we have what? I with what? 6 ohm resistor. Okay, so now we have what? Is 12 IN plus 12I, okay, plus what? 6I. So this will give us what? Okay, we have what? 12IN plus what? 18I, okay? 18I. That's what? Equation 1. Now, let's choose another loop, okay? Let's choose this loop. So this was taken in this direction, okay? Clean this one up. The first one was taken in this direction, okay? Was taken in this direction. Okay, so you take this one in this direction, okay? Right, so that's a current source, okay, or the KVL, okay? That's the direction we'll be taking, the loop, okay? Yeah, so let's say we have what? Loop what? So we have what? Loop CBEDC, okay? Yes, so we have loop CBEDC, okay? So that will give us what? We have what? 35, okay? 35 because what? We don't have any resistor here, so okay, the IN will be multiplied by 0, so that's 0. We have what? 6 what? 6I, okay? So we have our current to be what? 35 on what? 6, okay? And that will be giving us what? Okay, 35 on 6. Let's just leave it like that, okay? I wanted to put it in decimals, okay? But let's just leave it like that, okay? That's 35 on what? 6 amps, okay? Or amperes. 35 on 6 amperes. No. Now, since we know what I, and then we can substitute that into what? Equation 1, okay? So substituting I into equation 1. So substitute what? I, okay, into equation 1, okay? We have what? Substitute I into equation 1, we have what? 42, okay? Equals what? 12IN, okay? Plus 18I, okay? And then we know that I is what? 35 on 6, okay? So we have what? 42 equals what? 12IN, okay? Plus what? 18 on what? 35 on 6, okay? 35 on what? 6. So this will give us what? When you punch this, you'll get what? Making what? IN the subject, you end up getting what? IN to what? Okay, we have what? Minus 5.25, okay? Amperes, okay? That's our what? IN, okay? So IN is equal to what? Minus 5.25, okay? Now, let's move on, okay? So we are done with what? The remove, the insert, and now what? Kirchhoff's. Now we are going back to what? Our R, okay? That's the RN, okay? So we have what? RN, the R, okay? Now note that Rn, okay, is the same as what? RTH, okay? So the method you use in finding RTH, you can use the same method to find what? Your Rn, okay? So now let's draw this circuit again, okay? So we have what? By omitting the volts, okay? The voltages, we can just omit the voltages, okay? Have that, then we have this, okay? Right, so we have what? 12, 6, okay? 12 and 6, we've omitted this one. We have what? 12 ohms and what? 6 ohms with our what? Resistor, okay? Can this represent hereby what? Our resistor Rn, okay? Now, Now, so from here we could just notice that 12 and what 6 are in what parallel. Okay, in case you've not watched our first video or second video on parallel and what series resistors, you can just go back and then watch that. Okay, so let me just brief you on how to find parallel circuits. Okay, no parallel resistances. So whenever you see two resistances and then there is no other element like a voltage source or current source, and then you can traverse around them like this, okay, and then there's no other element, it means that they are what in parallel. Okay, so you have what 12 and what 12 and 6 in what parallel. Okay, so when you do the calculation, we have what 12 by what 6 on what 12 what plus 6. Okay, and that will give us what 6 ohms. Okay, so now we are done. Okay, so we are to just use this formula. Yes, to use this formula to find out what the current passing through our what I. Okay, so we have what the I, okay, is equal to what a certain Rn, okay, divided by what Rn plus what, let's say RL or R prime, then multiply by what IN. Okay, so we have what Rn is what 6 ohm. Okay, this is our what Rn. Okay, 6 ohm. Okay, so we have what sorry, let me just check this again. Okay, yes, this 4, okay, this 4 ohm, sorry, this is 4 ohm, right, this is 4 ohm, so we have what 4 on what 4 plus what RL is what the resistor we removed. Okay, that's what 3 ohm. Okay, and then multiply by what IN, that's what minus 5.25. Okay, so we have what minus 5.25 and what I. Okay, I will give us what minus 3 amperes. Now, one thing you need to know is that once your answer does not collate, it means that you are wrong. Okay, so you could notice that for using Thevenin's theory, we got for the same question we had a I to be what minus 3 amperes. Okay, yes, and then this one too for Norton's too, we have a I to what minus 3 amperes. Okay, it means that our solution is what correct. Now, instead of going through this approach, that's using your Thevenin, Rn and In and all that, you can actually use Thevenin's theory, okay, to solve a Norton's question. Okay, so that's what I'm about to prove to you. That's why I introduced this formula. Okay, the In equals what VTH on what Rn. Okay, instead of going through the Norton's approach, okay, using In, allocating short circuits, okay, and then using Rn equals what RTH and all that, you can just use the Thevenin's theory to find what your Norton's. You can just, what I'm trying to say is that you can implement Thevenin, okay, in Norton's approach. Okay, you can implement Thevenin's theory in what Norton's theory. Okay, so you can use Thevenin's answers, okay, the answer you get from a certain question by using the Thevenin approach to also solve a Norton's question. Okay, so this is what I mean. Let's move on to this question, okay, so that I'll just show you how you can do that. Okay, so again, put this formula in mind. Okay, keep this formula in mind. That's In equals what VTH or not Rn. Keep that in mind. Now let's move on. So this is the reason why you need to understand what the Thevenin's theory. The Thevenin's theory, as I said earlier in the previous video, is very simple and then what concise, straightforward. So all you need is what the Thevenin's theory to solve your what Kirchhoff's, your Norton's theory. Okay, now, so you could remember from our previous video that this was the question we solved with what Thevenin's theory. Okay, we use the RIKR approach over here. Okay, and then we remove our the resistor 5 ohm. Okay, and then we inserted our VTH. Okay, over here, and then we introduce our the currents and all that. Okay, using the KVL. Okay, and then KCL. Okay, and then we ended up solving using our loops. Okay, to find our respective currents in different loops. Okay, and then substitute to get our VTH. Okay, and then we went on to use our R. Okay, okay, to find our RTH. Okay, yes. So from here we got to know that some resistors are in parallel and others are in series, and then we did a calculation. Okay, and then we got RTH to go at 21 on what? There's our RTH. Okay, to what? 21 on 5, and then we ended up solving our I. Okay, to the VTH on what? RTH plus what? R prime, and we ended up with this formula. Okay, now again, you can use Thevenin's theory. If you really understand the Thevenin's theory, there's no need to understand the Norton's theory. Okay, this is why I will show you why right now. Once you understand the Thevenin's theory, and then you can solve questions with the Thevenin theory, you don't need to understand what the Norton's theory, but you just need this approach. Okay, so now this is the only formula you need for Norton's theory. So we have what? From Ohm's law, we have IN, okay, equals what? VTH, okay, on what? Rn, okay. And then we know that what? Rn, okay, is equal to what? R what? TH, okay. Now keep this in mind. Now, so from here we could notice that let's now find what? VTH, okay, VTH. So from this question, okay, let's find our VTH. So let's say you've been given this question, okay, and then you calculated for your VTH, and then you had your VTH to be what this, okay, this was VTH, okay. Now this is how you solve Norton's theory with Thevenin's approach. Okay, keep it in mind. You can solve Norton's theory with Thevenin's approach. Okay, all you need to do is to understand what the Thevenin's theory, and then use a calculation or formula approach to find your Norton's corresponding Norton values. Okay, so now this is our VTH. Okay, and then what? Rn is equal to what? RTH. So let's go find what? RTH. Okay, so RTH is what? 21 on 5. Okay, so now let's come back. Now we are just using the formula approach. So you know that RTH and what? Rn are equal. So you have what? 21 on 5 ohms, and then we have what? VTH, okay, to be what? Minus what? 4 on what? 5, okay, volts. So now all you need to do is find what? IN, okay. So IN, note you have to calculate for the Thevenin's VTH and then what? RTH, okay, before you can use it to find your what? IN, okay. So after finding your VTH and RTH, and then just substitute into this formula, okay. Keep this formula in mind, okay. You just substitute into this formula, okay. Okay, yes, so you have what? VTH to what? Minus what? 4 on what? 5, okay, divided by what? Yes, 21 on what? 5, which is our what? Rn or what? RTH, okay. So from that, you notice that our what? IN will be something like what? When you punch this on your calculator, you get something like a minus 0.19 something, okay. So you have what? IN to what? Minus 0.19, okay. So note, you are not done. This is where the trick comes in. So after finding this, you are done with the question. So all you need to do is just implement your formula, okay, this formula, okay, this formula, okay, the I equals Rn over Rn plus what? RL times what? IN, okay? That's all you need to do right now, okay? Just implement that, okay? So you have what? RI, okay, to be equal to what? RN, okay? All over what? RN plus what? Your R prime or RL, okay? Could be prime, could be L. Multiply by what? IN, okay? So from here, you are done. So you know that RN is the same as what? RTH from here, okay? So that's what? 21 on what? 5, okay? Divided by what? 21 on what? 5, okay? Plus what? We try to find the resistor, the current through the resistor, 5 ohm, okay? This 5 ohm, okay? This 5 ohm, right? So now we just bring that over here. We just bring that over here, okay? 5, and then you multiply that by what? The IN, okay? Could notice that there's our IN, so you multiply that by IN, we have what? Minus 0.19, okay? So when you punch this on your calculator, you will find out that you get something like minus 0.0867, which is approximately equal to what? Minus 0.09 what? Amps. So from here, you could notice that this I value using the Norton's theory is the same as the I value we had using the what? The Thevenin, okay? Using the Thevenin's theory. So let me show you over here, okay? So yes, this is the I value we had using the Thevenin's theory, and then this is the I value we've gotten using what? The Norton's theory, okay? You can notice that they are the same, okay? So again, all you need to do, or all you need to know, is to understand the Thevenin's theory. You don't need to understand Norton's theory, okay? Understand the Thevenin's theory. Know how to find your VTH, RTH, okay? And then you can implement that in solving for Norton's theory, okay? That's it. Simple as that. Straightforward, okay? In case you also understand the Norton's theory, it's a plus for you because you can also use the same Norton's theory, okay, to find out, just like what we did over here right now, okay? We just implemented the Norton's theory. So you can do the same thing for this one. All you need is what? Your VTH for this same question, okay? Your VTH for this same question, and then your RTH for the same question, and then you implement this formula, okay? So you use this formula to find your IN over here, and then you use this formula to find your I, okay? So after finding your IN from this formula, you insert it over here, and then you find out what? I, okay? So this brings us to the end of what? Norton Thevenin's theory, okay? So in case you are new here, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. You could subscribe and then do not hit on the bell icon. When that happens, whenever a new video is being uploaded, you might not even see it, okay? So hit or turn on your notifications, subscribe, like, share, and then let me know any questions you have for me in the comment section below. I will see you in the next video. Have a good day. Bye bye.